So this is the current state of the board game prototype I'm making. So let's go ahead and run it. So let's see, got this event log here. Zoom out, click to roll, right? Click to choose. The controls or whatever and the graphics are totally shit. But so here's my path selection arrow. You cannot go backwards the same way you've already come. But if I go down here, I can choose to go this direction now, right? And so there's only one player, so that their turn keeps going over and over again. I can go here or here. And it calculates all of the paths and handles all of that. And so, yeah, pretty cool little event log. Now I'll show you a little bit about the structure. So at the core, there's a few pieces. This is the gameplay as opposed to like a main menu or something like that. Then we have primary processes. This will bootstrap the entire process. It includes things like preparing the map, adding players, moving them to a starting position, which probably I can move somewhere else, but and it tells us, okay, the bootstrap's complete. The game process is really super basic right now. It just says, hey, begin game, start next turn, and then start next turn. It just keeps the turns rolling. Player turn says, okay, we rolled for movement. Let's move the player. And the player movement has complete. Let's end the player turn. So it's just basically saying a player's turn consists of rolling for movement and moving, and then the turn's over. Right? So that's the core of the whole gameplay process. The map is a scene, and it has things like line segments that connect nodes, and then the pawns themselves. And this is like a little pawn factory that just builds them when is appropriate. Animations is here's the movement specific animations. So pawn movement. Okay, if the player was moved to a starting node, right, then we move them there, like just basically teleport them there. If the player moved, then we go ahead and run move pawn, which is this entire animation system. And the path decision arrow is like, it's a little bit complicated, but if a player arrives at a junction, then queue up the process of choosing a path. This way, the movement doesn't start and then the arrow to choose your path at the same exact time. Because you got to keep in mind that the domain is deciding, okay, we're moving from point A to B to C to D, and at D there will be a junction. It knows all of that ahead of time, and it just throws it all into the dispatcher. The queue allows you to queue up actions and behaviors, not just animations, but basically anything, so that things happen in a sequential order instead of just boom at the same time that all of the events hit, because they're going to be like on the same frame or two frames or something like that. So the way that works is when you add yourself to a primary queue, and right now I only have a primary queue. I can make as many as I want to because it's just like this. So primary queue channel, I can just duplicate this and say secondary or UI or any specific feature. I'll have to figure out how to design that over time. Um, but once the player, okay, so you add them to the queue, and then you have these signals, start and end. When you add it to the queue, that's it. The queue decides then, okay, you're next. It's time for your turn. It runs start. This is where we start the animation, blah blah blah, and then you decide when to call end. Not the queue, of course. You decide when to call end. The way you do that is you emit the signal end. So in this case, once you confirm your choice at the junction, right? You submit the command, you'll get a domain event back that says player chose where to move. Now, this decision arrow, path decision arrow doesn't need to exist anymore. It runs end, it makes it invisible, stops the animation, and it emits the signal end, which tells the queue it can remove it and start the next item. So pretty nice. So that's the core there. User interface is a player turn display, which is really neat. If I just go into the scene, I can hit play, and you can see that. Well, you can see that because it's just the run, but if I run only the scene, of course it doesn't run because it doesn't have the rest of the system the system in place. I can actually, what's interesting, since it's all event driven, I can actually bring in processes over to this other scene, and it will just run everything. It's really cool. So here's what it looks like when it's not. And here's also the animation. Yeah, okay. Ignore that. I haven't run that in a long time, so I guess I changed the way it worked. Cool. And movement roller. That's just the dice roller, which is like, yeah, choose a random number, roll it, blah blah blah, then send it back. You know, a game commands gameplay roll for movement. The reason the commands is this upper level thing is because it's like a global. These all here are global and available everywhere. And then I subdivide them by putting gameplay in here because again, menus and stuff like this. So the way that works is you have commands, and then under commands is gameplay, which is gameplay commands, and it's typed so that you have autocomplete and everything. And then in gameplay commands, you have all these commands right here: do this thing, do this thing. It's just a service layer for an entire mode of application behavior. Yeah, so that's my game prototype. It's a lot of design and redesign to keep it super simple. Like, here's my player domain object. Roll for movement, right? Number rolled. Remaining movement is set to that number, and then it says that they rolled. Then when they move, it keeps track of the previous node and the current node, so it knows which one's behind it, so that when it arrives at a junction, or even when it's going on a straight pipe, it knows that what direction to go, right? And so it kills the remaining movement every time it moves, and if there's no movement left, it says player's movement is completed. Now if I look at the map domain object, this is kind of cool, because the map, I decided the map was going to be where all of the logic for traversal was going to be, because that just makes sense, right? And so when I go to move a player, we just decide if there's only one available node, that means they went to an end, like a dead end. So they get to that dead end, and the only node that's available is backwards. That's the only time we actually allow the player to move to the node that they were just at. So it's pretty straightforward. If there's only one node connected, then move them to it. If there's two nodes connected, find out which one is the node that they were just at, and move them to the other. Finally, if there's more, then we determine what are the options they have by looping through all of the connected nodes and determining which one they were just at, and including the rest. Then we say, okay, the player has arrived at a junction, which will bring up a new domain event, and then we just dispatch that. And that's how all of the movement is actually done. It's pretty fun. I love the thinking through the logic. Dead end. Oh, automatically move back. Now these are sequential, so automatically move because it knows that you can't move backwards. And so see here, even it knows the previous one. I can't go left. I can't go up. There's nothing up. But I can go here, and then because I ended up here. And because I went that way, I can go here. Now because I came back, I can go here. And that's the intended behavior. Well, thanks for watching. Like and subscribe.